Okay, hi again. A new video in computer aided manufacturing. This video will concern with the canned cycle. Canned cycle or fixed cycle is part of computer aided manufacturing. We refer to computer aided manufacturing where we use numerical control software application to create G code or detailed instructions which will control and drive a computer numerical control machine to manufacture the parts. So this is a definition of computer aided manufacturing. It is a code, machine, and final product. To facilitate the creation of that code, there are what we call canned cycle or fixed cycle. Canned cycle used to make it easier for the programmer to generate and to create and to develop his G-code program. So using this canned cycle will make it very easier and quicker and save effort and time and even the computer program memory itself. Why the name canned? Canned comes from canned goods, canned goods, canned products. So when we talk about canned, it means we package certain amount of goods or certain amount of foods or certain amount of juice or drink in a can and keep it and store it for later use. So this is very similar to what we mean by canned cycle. So it is something stored in certain container. What is stored is set of instructions, certain of repeated pattern, and we keep it in that can or in that container for later use in the program. Normally canned cycle start with like any CNC statement with the G code function. And it can be single block or more than single block, but it is almost single block. And within that block, we store a certain amount of routines or a group of instructions. What canned cycle we will discuss in this session? We will discuss this list of canned cycle G codes. This is what we're going to use and what is we going to discuss. Every one of these G canned cycle code has certain function. It can do a sort of repeated instructions and actions. Before we start to deal with this code, let us first identify very important positions or tool levels. Levels of tool, different tool levels. As we see here, this is one level, second level, third level, and fourth level. So we are talking about 4 levels. And this is the workpiece. The tool will create certain process on this workpiece. That workpiece is supported on the machine table. What about these levels? The first level, we call it the safe rapid level. This is the one. It implies the meaning of safe rapid level. Safe means when the tool move in that level, it will be safe. There will not be any obstacles. There will not be any clamps or any fixtures or any something which make interference with the movement of the tool. So this is the rapid level. Sometimes we call it initial level because at this level the tool still does not do any action. So it is initial position. It is a specific position. We specify that level. We bring the tool to that level from which we start our canned cycle. So whenever the equipment brought to that level, then the canned cycle will start to become effective. The second level is the rapid level. Rapid means the movement of the tool from the safe or initial level to the rapid level will be in rapid feet, in rapid speed. We call it R, rapid level, which is the end of the high movement or high speed movement or the rapid movement. Normally that level is your choice, your selection. Of course, every level is your selection. It is your choice. But normally we select this level, this rapid level, 2.5 millimeter above the surface of the workpiece. A sort of clearance between the surface of the workpiece and the rapid level with this amount, 0.5 to 2.5 millimeters. Why we need this amount? We need this amount to provide a steady approach when the cutter touch the workpiece to be already settled at its feed speed and feed rate. Starting from the rapid level, the movement, the coming movement will be in the feed amount. It will not be rapid. It will be your feed amount. You decide how fast your tool will travel, will do the required action. So the third level is the top of the material top. This is the material top. Of course, this will by default will be based on the geometry of the workpiece, the size of the workpiece. Whenever the tool starts from the rapid level, it will start with the feed movement until to the end of the process, whatever the process is. Could be drilling, could be boring, could be tapping, whatever the process. So whenever it ends the process, it comes to what we call the Z level. The Z level. So the Z level is the final travel of the tool movement with a feed value. After this Z level, the tool will retract again. It will retract again. The retraction could be varied, could be rapid retraction, could be with feed value, whatever. So when the tool retract, it can either retract to the R level or it can retract to the initial level. Who control these two choices? The one who controls these two choices is another G code, which is G98 or G99. G98, if you use, it's up to you. You choice, you select whatever you like. Whenever you select G98, so the tool will retract to the initial level. When you select G99, the tool will retract to the R level. So this is the difference between G98 and G99. So back to this definition, if the tool retracts to the initial level, it will be 98. If the tool retracts to the R level, it will be 99. You are the one who decide which you like. It depends, of course, on the coming action after completing one candy cycle, and maybe you need another candy cycle, so you decide what is the level of retraction, of tool retraction. Let us start with one of the candy cycle. We call it the tape cycle. What is the meaning of tapping? Meaning threading, internal threading. So we use a thread tool, a threading tool. We call it tapping process. Tapping process means creating a thread, internal thread, on holes which is already drilled. So in the candy cycle block, the candy cycle will control all the requirement to accomplish the tapping process. Tapping process is one of the complicated process because it requires certain program, certain procedures. It is not simple like drilling or boring, or it is a special one. First, we position the tool in XY direction. We position the tool in XY direction like this. So this is the tool already positioned in the XY direction. Then after positioning the tool, it will make a rapid movement to the R level. So first of all, we bring the tool to XY position, to the initial level, then rapid motion to the R level. Then the feed will start. Feeding motion to the Z plane. So from the R level to the Z plane, there will be a feed motion. It will not be a rapid motion. Then at the end of the Z, or at the Z plane, or at the end of the tool travel, there will be what we call command motion. Command motion means something will be taken here before retraction, before tool retraction. Command motion could be reversing the direction of the spindle, could be waiting for some time, and so on. So this is what we call commanded motion. You give a command to the tool to do some action. That action could be dwell, could be spindle stop, could be spindle reverse, or spindle orientation, or spindle lateral shift. Lateral shift means move in the lateral direction, especially if we are doing boring or enlarging the internal size of the hole. After that, after this command action, there will be a rapid or feed return to the R level or to the initial level based on G98 or G99. Here will be a feed motion. It will not be a rapid motion. It will be a feed motion. Why feed motion? You reverse the thread, the spindle direction, then you following the same path of the tool, with the tooth being created in the lower direction. So you following the same route, the same tooth which already been created in the previous direction. There is some special characteristic of the candy cycle. Special characteristic means it will be by default. It will be applied as a default. What about this special characteristic? The first one, if the tool is already on certain location, there is no need to program X and Y again. Assuming at certain location, you will do drilling followed by boring, followed by tabbing. So 3 processes will be done at the same location. So when we use candy cycle, we might need to use 3 candy cycle, but X and Y will not change since it is in the same position or in the same location. The second characteristic of the candy cycle is in effect until it being cancelled or replaced. What it means? It means if you move the tool in XY direction, the same candy cycle will be active whenever the tool move in X or Y direction, whenever the tool change its position. So subsequent location, subsequent movement of the tool can be machined by programming X and Y in subsequent block without it changing the candy cycle if the candy cycle will be required in the second position. We will see some application about this characteristic. If you do intend to perform the candy cycle in the new location or in the next location, because it is still active, so you have to deactivate. How to deactivate? By cancelling the candy cycle. So to cancel the candy cycle, we use G80. If you don't cancel the candy cycle, if you don't cancel the cycle, it will be active in the second position. What is the meaning? Assuming we are doing drilling in one location. Suppose this is the location we do drilling. So we did the drilling here with candy cycle, or we do tabbing with candy cycle, whatever it is. Then if you move the tool to another location and you don't intend to do drilling or tabbing in the second location, first of all, you have to use G80 before going to the second location. Otherwise, the tool, whenever it go to the second location, it will create the same candy cycle which has been created in the original location. So if you don't need that action, then you have to cancel the candy cycle by using G80. So for example, this is G80 to compare between G98 and G99. Back to this definition, using one of the candy cycle, which is the drilling candy cycle, G81. We use G81 as a candy drilling cycle. The action of G81, once you bring the tool to the position, to whatever position of the location of your hole, then the tool will wrap it to the R label. So that is the R label. This is the initial label, the R label, material top label, and this is the Z label. So what is G81 is doing? G80 is doing all this in one block. It will move the tool in Z direction with rapid movement to the R label. Then it will move the tool with feed motion to the depth of the cut, depth of the tool. Then it will retract the tool, either retracting to the R label or retracting to the initial label. In this case, we use G98. So using G98 means it will retract the tool to the initial level. This is the same. The only difference is instead of using G98, we use G99. In that case, the retraction will be to the R level, not to the initial level. So this is the sequence of the drilling cycle as we explained. This is the different steps of the G81 candy cycle. This is the first can cycle. We already use G80. So up till now, just to review with you whatever we already used, we use G80 for what? For cancelling the candy cycle. As an additional cycle, we use G98 or G99. This is not a candy cycle, but it is used with the candy cycle. Now the first candy cycle we used now is G81. This is for drilling, and this is the sequence of G81. It will do all that steps in one line. So only one line instead of using 4 lines in your CNC program, you only use one line. How this line looks like? This is how it looks like. It starts with the candy cycle under consideration, which in our case is G81, and the X and Y and Z. This is to bring the tool to the initial level, initial position. This is X, Y, Z here. This is the function of X, Y, and Z here. Of course, referring to the 0 point or the original point. Then R is the R level. Where is the R level? And the F is the speed. F is the speed. And Z will be the depth of cut or the end of travel. And the F is the feed rate. F is the cutting speed or cutting feed rate. Assuming we apply this candy cycle G81 to this group of holes. Assuming we have this group of holes, how we can apply candy cycle for this group of holes? What holes we have here? We have 3 groups of holes. This is the first group, this is the second group, and another group in the middle. They are numbered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the top view and this is the front view. So this is the workpiece, and we're going to apply this G80 candy cycle to drill these 3 group of holes. The first group, which has 4 holes, is the same as the second group in size. So we will use the same tool to drill these 2 groups. Then we change the tool with another size to drill these 2 holes. Let us see how we can apply G81 for that task. First of all, we start as usual the block number and selecting of our tool and tool change and spindle start. Then we use the coordinate system, absolute coordinate system, G00 rapid movement, XY. What is XY? XY, if we refer to this drawing, this is the original point, this is the 0 point on the top plane, and this is the 0 point on the front plane. So when we select X equal 10 and Y equal 30, it means this is X equal 10, Y equal 30. It means we locate our spindle above that position, above the first hole. So what is the meaning of Z equal 12? Z equal 12 means from that position we will locate our tool on the Z direction with this amount, which is 12. Why 12? To clear that height, So we allow 2 millimeter above that level, so when the tool move, it will move and not interfere with this shoulder or with this high spot. And this is our speed. and this is the MO3. Then we still not using, we just prepare for the candy cycle. So this line or this block is to prepare for the candy cycle. So we locate our tool and we select our tool, whatever the tool we're going to use. Tool number 1, and we select what speed. So all this is a preparation for the candy cycle. The candy cycle starts at this block. It is one line. Candy cycle located in one line. But X and Y already prepared in the line before. Here we select G99 to retract the tool to the R level, not to the initial level. And the G81 is the candy cycle, which will do that routine. And Z, when Z comes after G81, it means the final depth of the tool during cutting. So Z is minus 17. Minus from that 0 position. Minus 17 means 15 plus 2. So when the tool comes, it will come like this. This will be the drill. It will be like this. So we allow this 2 millimeters. 2 millimeter. Why we allow this 2 millimeter? Remember that this twist drill, it has this shape. It has this shape. This angle is almost 118 degree. This is a standard tool point angle. It means that half angle is almost 60 degrees. What it means? It means if that is 2, that will be 1. It means if the diameter is 4, you should allow 1. So make it as a rule of thumb, that this allowance, this amount, should be 1/4 of the drill diameter. 1/4 of this diameter. So whenever we allow 2 millimeter, it means that this diameter almost 8 millimeter. So make it as a rule of thumb. So this is the final. R is 2. What is the meaning of R is 2? It means the R level will be 2 millimeter above the material top. It will be above the material top. That will be the R level. So we define the 4 levels now. We define by this part of the program, we already define the 4 levels. What is next? Up till to that point, we create the first hole. We create the first hole, that one. So what do you expect about the second hole? We will apply the same candy cycle as the second and the third and the fourth hole. So we will not repeat that cycle again, because as we mentioned before, this is one of the characteristics of the candy cycle. It will keep the candy cycle active. So what we're going to do, just modify the position, just update the position. When we update the position to position number 2, it will repeat the same cycle with the same configuration at hole number 2 and the gate number 3 and the number 4 and so on. So what we're going to do in the next block, we just change the Y value, because X is the same. Yes, this is the Y value. Now Y, instead of it was 30, now it is 10. So what about the third hole? The third hole, we change the amount of X. X now, it will be 30. Yes, because this is 20 plus 10. So the location of hole 3 is 30 measured from the original point. What about when we intend to go for the whole 4? Now we change the value of y. So y in that case will be 30. This is the y of the whole number 4 measured from that original point. Then we finish this group. What about the second group? Now we'll move to the second group again, but before we go, we should retract our tool. To retract our tool, we use G98 to retract it to the initial position, because if we're not using G98, if we make a mistake here and use 99, whenever the tool move, it will interfere. It will make a collision with that. It will break the tool and it will break the workpiece. So we have to retract the tool to the safe level, to the level which is above that shoulder. So that's why we use here G98. Then we use G98, and on the same time we can use it with the same line or another block to move again in to the with x equal 90. X equal 90 means this is the amount of 90. This is the 90, which is 10 plus 20 plus 60. So it means we move to that position. Myself, I prefer if we can make this into two blocks, not in one block. First to retract, then to move. It's better if it is in 2 blocks instead of 1 block. Okay, after doing that hole, which is either number 5 or number 6, depends. We've been before at number 4, so we come to number 5 here, because the same y is still acting as number 4. So what about next step? Next step is to move from 5 to 6. In that case, we will change only y. So y in that case will be 10. Yes, y will be 10. So what about the next hole? Here we will change x. X will be 10 plus 20 plus 60 plus 20. So it will be 110. So we come to hole number 7. What's next? After 7, we go to hole number 8. So what we're going to change? We're going to change y. So y here will be 30. Yes, y will be 30. Once we finish that group, now we have again to retract and to change our tool to complete the other 2 holes that in the middle. So we move. We first cancel the candy cycle. G80 cancel the candy cycle and send the machine to the 0 point where we change our tool, and M05 to spindle stop, ready to change our tool to tool number 2. Tool number 2, of course, it will be in a bigger size compared with the first tool, tool number 1. After I changed tool number to tool number 2, now we will position our tool on the top of the hole number 9 by bringing the tool to above hole number 9. What is the location of number 9? Let us estimate the location. Let us know the location. 10 plus 20 plus 60. So it will be 90. So it will be tool number 10 plus 20 plus, sorry, this is not 60, this is half of 60, so that is 30. So 30 plus 20 plus 10, so it will be 60, yes. And what about y? Y will be 12 plus 16, so this is y, measured from the original point, so y will be 28. And what about z? Z again, the same z, above the shoulder by this amount, so z will be 12. Z will be 12. So bring the tool, and we assuming or deciding the amount of speed, then spindle start, then G99 and G81 again, we activate the candy cycle again, and Z minus 17 exactly like we did before, allowing 2 millimeter to clear the point of the cutting tool. Remember that this height is 15, so you drill the hole, but you add 2 millimeter. It should be better, it should be greater than 2 because the drill here is bigger. It's better if this one is 20 instead of 70. And the R is 2 and the feed, and now we drill hole number 9. What is next? The final hole will be drilled now, which is number 10. We keep the same canned cycle. What we're going to change, we're going to change the amount of Y. Instead of Y, it was 28. Now Y should be 12. Yes, Y will be 12. That's it. So we end the program by M30. So this is an application of that type of cycle, of canned cycle, which is G81.